JMath.
Hi guys, welcome to a video on calculus graphs. So calculus in an exam has three sections. The derivative and the first principle section, then the middle one is called the graphing section, where you're either going to sketch a graph or you have to interpret a graph, and then the last one is optimization, where they give you a word sum or anything in that line that you need to solve. So first thing, sketching a cubic function. There are 5 steps, sometimes just 4. So step 1, you are going to look at the a value. So it is the coefficient of x cubed. If that is a plus, your graph would be increasing, then decreasing, and then increasing again. So it goes up, down, and then up again. So a graph that goes up twice is an increasing graph. Then obviously the opposite, if a is negative, then your graph goes down twice because it's then a decreasing function. So you need to figure out, is it increasing or decreasing? Step 2, get the y-intercept so you can make all the x's 0, or you just look at the d value, because that is the constant one that will never change depending on x. So once I have that, I can write that down. Then step 3 is the x-intercepts. Now that's, for many people, that's the most difficult one. Okay, so you need to factorize the cubic expression. Now, please go check the video that we did on how to factorize cubics. There are 4 main methods. If you have the white calculator, this step is very easy. Otherwise, you need to choose one of those methods to get the x-intercept. Sometimes there's 1, sometimes there's 2, and sometimes there's 3. Make sure you know a method to work that out every time. Step 4 is to get the turning point, make the derivative equal to 0, and then you find x. Once you have that x, you sub that back into the original formula. Remember, fx is equal to y. So if I'm ever looking for a y value or a coordinate, I'm going to sub x into the original. If I'm looking for a gradient, I'm subbing x into the derivative. And remember, at a stationary point or a turning point, the derivative is always equal to 0. That's why step 4 is make the derivative equal to 0 and solve for x. Okay, now if I want the point of inflection, I make the double derivative. So the derivative of the derivative. I make that 0, solve for x, and then sub that x back in the original to get y. Now, I forgot to mention, in step 4, you sometimes get 2 answers. Most of the time, you'll get 2 turning points. But sometimes there's a graph that only gives you 1 turning point. That's fine. Just follow your steps, and then you'll see what the graph looks like. Okay, let's actually do a few questions so you can see how the steps work in practice. Question 1, sketch the graph of fx equals x cubed minus 12x squared plus 36x. So I'm going to make my little list of the 5 things I just mentioned up there, and I know a is equal to 1, so therefore my graph would look like this. Step 2 was the y-intercept. I can't see a d value, so then that means my y-intercept is just 0 and 0. Okay, step 3, I need to find the x-intercept, and I get that by making y equal to 0. So if I just rewrite, I'm going to say y is equal to x cubed minus 12x squared plus 36x. I now need to factorize. Now, luckily, this is an easy one. You could have done this in grade 9 already. So I'm just going to take out x as a common factor. Then I'm left with a trinomial. So x squared minus 12x plus 36. And if I factorize that, that's just going to give me x minus 6, x minus 6. Okay, perfect. Now I just need to solve for x. So therefore, x is equal to 0, or x is equal to positive 6. Now, something that's very important, if you see that 2 of your brackets are identical, that means that value is actually a turning point as well. So I can then, for my 3 x-intercepts, I can say it is 0 and 0, and then the other one was 6 and 0. So remember, I don't need to go looking for y. I found this by making y 0, so that's why the x-intercepts all end on a 0. Okay, so now step 4, get the stationary points or the turning points. Now, I already know 6 and 0 will be a stationary point because 2 of my x-intercepts were the same there. But let's follow the steps and just make sure. So to get the turning points, I make the derivative equal to 0. So derivative of f, I know that's equal to m, but that's also equal to 3x squared minus 24x plus 36. I want to make that equal to 0 because at the turning points, the derivative is always 0. And I'm simply going to divide by 3 as well. So that's just x squared. That is going to be 8x, and that's just going to be plus 12. So if I factorize this, x minus 6, x minus 2, and just like I predicted, one of my turning points will be 6. Okay, so I just need to end the question now and say, therefore, x is equal to 6, or x is equal to 2. Now, I want the y value as well for those points, so I need to sub that back into the original and see what my y value would be. My mental math, no, I'm joking, my calculator tells me that is just 32. So I know my other turning point is then 2 and 32. I don't even need to sub the 6 in. I know it's going to be 0 because it's an x-intercept. Okay, and now for point 5, I am going to get the point of inflection. So the point of inflection is the derivative of the derivative. So I'm going to say f, two little lines, and then x is equal to, okay, I'm looking at my derivative, 3x squared minus 24x. I can then say that is going to be 6x minus 24. And I know I'm saying I'm going to make that equal to 0. So then this is x is equal to 24 over 6, which would just equal 4. Okay, great. So now I can also just sub in 4 into my original equation, and that would then give me a 16. Okay, now I have all the dots, I can plot them, and then I can draw this graph. So this one is actually going to be in this top right corner, so I'm just going to zoom in a bit, just so it makes a bit more sense. Okay, so I know the shape, not going to do anything with that. I know my y-intercept is on 0, 0. Then for the x-intercepts, I know there's an x-intercept at 6. Then for my turning points, I know there's a turning point at 6 and a turning point at 2 and 32, so that's up there. Okay, so now I have all the dots that I can put in the point of inflection. I normally wait with the point of inflection to first draw the graph and the curve, and then I put in my point of inflection in there. Otherwise, the graph has a weird shape, and it doesn't look nice. So another tip I can give you is when you're plotting the turning points, make a little bucky for yourself. So I know this top dot at 32 is going to be the place where it curves down. So I'm just going to make a little bucky for myself there. And the 6 is an x-intercept. So sometimes it's going to go through the 6. But other times it's going to turn there. So in this case, it's a turning point. So I'm going to make a little bucky there as well. And now I know it must start at the bottom left here. It must go through 0, 0. So my graph goes up, then it goes to the other bucky, and then it goes up again. Okay, and now I just need to see if my point of inflection is accurate. And according to calculations, it was 4 and 16. So 4 and 16 would be there somewhere. Just make the dot a bit bigger and no one will moan about anything. Now, to end off my graph, I need arrows on both sides. I need to put in all the coordinates that I can't clearly read off. So I must tell them that's 2 and 32. That's 4 and 16. And the 0 and the 6 they can see. So perfect. That is my graph. I can just put a label next to it and say that is F. Okay, so there's a lot of steps, but you can score nice marks with questions like these. Sometimes it's 4 marks, sometimes it's 6 marks. Just study the recipe and you can make sure you get these marks. Question 2, sketch the graph of fx if it is equal to minus x cubed plus x squared plus 5x plus 3. If I start with my list, a is minus 1, so therefore I know my graph is going to be like this because it's going to decrease twice. If I look at my y-intercept, I can see that's going to be a 3, so I can already write 0 and 3. And now this one is not as nice as the previous one. I'm actually going to have to work out what the x-intercepts are. And out of those 4 methods, you are welcome to choose one. In this specific example, I'm going to do synthetic division. If it doesn't make sense, please go and watch the video on factorizing cubics. But to start off with, I need to find a factor. So I need to find a number that when I sub it into x, it gives me a 0. Okay, so I know I'm going to have to sub something in there. Okay, so my options are going to be a 1 or a 3 because it needs to give me the last term. And I can do a plus or a minus with this. I don't know. So I'm going to guess minus 1 in this case. And let's see if it works. Minus 1, minus 1, minus 1. Now, minus 1 cubed and times a minus will give me just positive 1. And then minus 1 squared will still give me plus 1. Then minus 5 plus 3. And that would actually give me a 0. So therefore, x plus 1 is a factor. Remember, always the opposite sign. Okay. So now if that's a factor, it means that's one of my 3 brackets. Now I'm going to start the synthetic division. And remember, that's an upside down little dividing house. Okay, I'm going to put minus 1 there. And then the coefficients of that equation is going to come in the top row. So minus 1, plus 1, 5, and 3. Okay, this is also a 0, and I'm hoping this is going to be a 0, but let's not get ahead of ourselves. Okay, so first step, I am going to add these 2. So if I add them, I get minus 1. Then I'm going to multiply these 2. If I multiply them, I get plus 1. Then I add again, and I multiply again. Okay, that's going to give me minus 2. If I add, that's going to give me a 3. And then I multiply, that's going to give me minus 3. And then I end with a 0, so I know I'm correct. That means that this whole expression can factorize into 2 brackets, namely x plus 1, and then minus x squared plus 2x plus 3, and that should equal 0. So to get my brackets, I'm just going to say this is x plus 1. And then with this one, I'm not going to make it equal to 0. And then I can change the sign. So let me just do that separately. So I'm actually just going to say x plus 1 equals 0. So x equals minus 1. We knew that. And then minus x squared plus 2x plus 3 equals 0. And I can then just divide everything by minus x squared minus 2x minus 3 equals 0. In brackets, that would be x minus 3, x plus 1. And therefore, x is equal to 3 or x is equal to minus 1. Okay, so quite a long method, but it is better than algebraic long division. and it is a bit quicker than the inspection method as well. So I can then update my list and say, I know that -1 and 0 would be an x-intercept, and 3 and 0 would be an x-intercept. Once again, like we saw in the previous question, if I get a duplicate, so my -1 was a duplicate for x-intercepts, then that is automatically a turning point as well, or a stationary point. But I still need to officially go through the steps to find the other stationary point. Okay, so let me just make myself some space, and you can now see how I worked out the x-intercepts. Sorry, I'm going to take it away to work out the turning points as well. Okay, just like magic, it's gone. So now I can get the derivative and make it equal to 0. So the derivative of this whole expression would be equal to -3x squared plus 2x plus 5. Okay, I need to make it equal to 0, and then I need to factorize this whole thing. I don't like the minus in the beginning, so my first step is going to be to change all the signs. So -2x minus 5. Now in brackets, I know that's going to be a 3x, and that's just going to be an x, and I need to decide where I'm going to put the 5 and the 1. So I want the 5 there and the 1 there, and then a minus and a plus. Okay, guys, I'm not going to go into trinomials in this video, but please make sure you can do this when you write your exams. Okay, so therefore, 3x minus 5 is equal to 0, or x equals -1, or x plus 1 is equal to 0. So therefore, x is equal to 5 over 3, or x is equal to -1. We know when x is -1, the answer for y is going to be 0, but we can now just work out what the y value is when x is 5 over 3. And if I just do a bit of mental math, my answer is definitely going to be 9.48. Okay, no, just type it in your calculator and get the answer. They don't care about all the calculations to get there. Okay, last step, I need to get the derivative of the derivative and make that equal to 0. Just going to fit it in there. So the double derivative in this case is just going to be -6x plus 2. Therefore, if I make it equal to 0, this is going to be x is equal to 2 over 6, which is just a third. And then I can just sub in that third into the original to get the y again. And if I do that, the answer is 4.7. So 0.5 on my list is then just going to be 1 over 3 and 4.7. Great. Now I have my 5 points. I can put them on the graph and then just draw the function. So I can start with making my y-intercept, and I can see the y-intercept is going to be at 3. Okay, then I'm going over to x-intercept. I can see there's an x-intercept at -1 and an x-intercept at 3. I'm going to my turning points. So the -1 is actually a turning point. So I'm going to make a little bucky. And then my other turning point is at 5 over 3. And it goes all the way up to almost 9.5. So I'm going to put it there. And it's a turning point or a stationary point, so I can make a bucky again. And now I have 4 dots. I can see where it turns. I can see where it needs to go through. And I can see my shape needs to look like that. So I'm actually going to start top left and draw it towards the bucky. Then from there, through the y-intercept to the bucky. And then all the way down through the next x-intercept. Now, if I look at my point of inflection, that's at a third and 4.7. So I'm missing it a little, but if I put it there, no one's going to moan too much. And then I just need to put in all the coordinates that you can't clearly see. So 4.7 is there. This is then 5 over 3 and 9.48. And the other dots you can see clearly. I'm just going to put a 3 there for my y-intercept. Great. That is drawing this cubic function. Just need to label it as well. And for that, I will get full marks. Question 3, sketch the graph of fx. Okay, so now it looks completely different to the others. The others had 4 terms and no brackets. This thing has brackets. Okay, you are actually very lucky when they give you this because it's so much easier to work out the x-intercepts and the turning points and everything if it's in this format. So let's start. And again, my steps are going to be the same. I'm going to look at my a value, and my a value is whatever is in front of this bracket. And there's a +1 if you can't see anything. So therefore, this graph is going to look like this. Or, spoiler alert, it's going to look like a tan graph maybe. And if I can tell you, if it's in this format with the bracket cubed, it's always going to be the one that looks like a tan graph. Okay, and if this happens, my turning points, there'll only be one turning point or none. And most of the time, that is going to be my point of inflection as well. I can now tell them the shape. If I look at my y-intercept, I can't just say it's -1, and I actually need to go work it out. So I'm going to say y is equal to 0 plus 2 cubed minus 1, and that's just going to be 8 minus 1. So my y value in this case is 7. So 0 and 7 I can write there. Okay, x-intercepts, no complicated methods or nothing. I just make y equal to 0 and then solve for x. Now to make it easier, I'm just going to move the 1 over and get the cube root of 1, and luckily for me, that is just a 1. So this is 1 minus 2 would be x, and therefore minus 1 is equal to x. So I can just say -1, and 0 is my x-intercept. See how much nicer that is than the previous one? But yeah, you don't get a lot of these in exams. They love asking the long, exhausting one. Okay, next point, to get my turning point, I normally make the derivative equal to 0, but in this case, I can just say this is the x value and this is the y value. So if it's in this format, they give you the turning points. Just remember to always change the sign of the number in brackets. So this is -2 and -1. Okay, guys, so it's only if it's in that specific format with a bracket cubed that you can do that. And when it's like this, my point of inflection is going to be the same as my stationary point, so I don't need to work it out. Great, that's all I need to work out, and now I can just sketch the info they gave me. So my y-intercept is going to be all the way up there at 7, my x-intercept is at -1, and then the turning point, or the point of inflection in this case, is 2 left and 1 down. So like I said, this needs to look like a tan graph, and it flattens out a little bit at the turning point, and then it just goes up and continues to go up. Okay, so mine made a little wobble in the middle. They're not going to care too much about that, but please focus on neatness, that it doesn't look too horrible. Okay, so now I can put a -2, -1 in there. They can see all the other points, so I will get full marks for that graph. The last graph is always considered as a trick question because people don't know what to do if I see all this info, and they just need to figure stuff out and they don't have the values of A, B, C, and D. You can't get a derivative. Don't panic, don't freak out. It's actually quite easy if you get a question like this. So I don't know the shape. I can't see what A is. So I'm just going to leave the shape for now. Question 2, I'm looking for the y-intercept, and the y-intercept I get if I sub in 0 into the place of x, and that is that value that they give me right there. So my y-intercept is going to be 0 and 32. My x-intercept is if the answer of fx is 0, so there I can see an x-intercept, and there I can see an x-intercept. Okay, so I can rewrite that as -2 and 0, and the other one as 4 and 0. Okay, now the next line tells me the turning points, because remember, if the derivative is equal to 0, it shows me where the turning points are. But very, very, very important, they are not giving me the y value of the turning point, they're only giving me the x value. So I know this has a turning point at 0, and it has a turning point at 4. I now need to go and look for other info to see what the normal y value was at those dots. Now, if I go and look, what did I get when I sub 0 into f? And the answer was 32. Okay, and then what did I get when I subbed a 4 into fx? I got a 0. Okay, see, so now I'm getting more and more pieces to this puzzle. Okay, now I can actually go and make those dots, even if I don't know what the shape is or anything like that, and I can see, okay, I have a turning point at 0 and 32. Okay, so way up there, I have a turning point, and it is my y-intercept. Then I also have a turning point at 4 and 0. Okay, and the other point that I have is -2 and 0. There's an x-intercept. Okay, now I can't just assume the shape, but it's pretty clear what the shape would be. I need to look at other info they're telling me. So they are telling me the gradient, so the first derivative, is positive when x is smaller than 0 and when x is bigger than 0. Now remember, if the derivative is positive, it means the graph increases in those places. So in this case, my graph is increasing all the way up to 0, and then it's increasing when I pass 4. So that clearly shows me that the shape is going to look like this. Okay, so now I can, with my turning points, I can make my buckies again, just to make my life easier, and I can make a bucky there as well. Great, and now I can just go and connect. So it's going to start down there somewhere, go to the bucky, connect the two buckies, and then go up from there. And for that, I will get full marks. So that was the video on sketching cubic functions. I don't think it's too difficult. If you just remember all of these steps like a recipe, then you can work out the 5 points, put them on the graph, and then just get all your marks. There's way more difficult calculus questions than sketching, so please make sure you get full marks for this section in the paper. We are also going to do a practice video on this, so if you feel your skills are ready to test, please try that video and see how it goes.
If this video helped you, please like and subscribe.
JMath.